Hi folks, today we're going to cover the 30s. Feel free to pause this video at any point in time to take notes. The first little bit of this presentation is going to be some terminology. So what does dynamic mean? Dynamic means in constant change or constant motion. What does equilibrium mean? Equilibrium means balance. So we put the two together, we have constant change but balance. So dynamic equilibrium is established once the rate of the forward reaction and the reverse reaction are equal to each other. So that means in a beaker or in a test tube, the making of the products and the products coming back together to make the reactants are occurring at the exact same time and at the exact same amount. Another way of putting it is there's constant motion between the products and the reactants at dynamic equilibrium. And dynamic equilibrium is sometimes called chemical equilibrium or just equilibrium. Again, feel free to pause this at any point in time and take some notes. I would really like you to put this into a search engine and watch the 7-minute video. It is pretty decent. It'll clear up a lot of the information that we cover in this unit. Write down the Chatelier's principle. Take a second and do so. If you can't, just write it down from here. If a system at equilibrium is subjected to a stress, then the reaction will shift to lessen the effect of the stress. Again, pause the video to do whatever you need to do to take notes. In industry, Le Chatelier's principle is used a lot to get the most amount of the product, the quickest and the cheapest. So today we're going to be talking about a lot of shift. There are 5 stresses for a chemical equilibrium system. Those would be changing the temperature or energy, changing the pressure, changing the volume, which will change the pressure, addition of a reactant or the addition of a product, or the removal of a reactant or the removal of a product. Again, pause this and take some notes. Some rules that go with Le Chatelier: not all of what is removed will be replaced by a shift in the chemical reaction. And not all of what is added will be removed by a chemical shift. So the reaction will try to replace whatever is removed and remove whatever has been added to it, but it can't do it 100%. So in this instance, we have 2 chemicals. We have A and we have B, and they come together to make AB, which is a red compound. So A and B are colorless. AB compound is red in color. Imagine the following system at equilibrium. The colorless ions can link up to form a red-colored compound. The red compound could split apart into colorless ions. All 3 ions are present in the solution at equilibrium. So this might be what the solution looks like. The redness does not change because the red making equals the red losing rate. So again, this is what it would look like overall, so the red wouldn't change. The reaction is as follows. So this is a real chemical reaction. We got iron ions and thiocyanate ions making iron thiocyanate. This is clear and colorless, and here we have a red pigment that shows up when the two come together. So on the left-hand side here, we have what a microscopic view would be, actually smaller than microscopic. And then this would be the macroscopic. In other words, if you looked at a beaker, it would appear to be red. So again, we have colorless, colorless formed together to make red. So if I add some more Fe, and the equilibrium is achieved by shifting which direction? So think about that for a second. Maybe you can pause the video and see what you can come up with. So we're adding more of this. That is our stress. This is going up, so the reaction should shift to try to use up some of that iron. So it's going to shift that direction and make a red compound. So it's going to shift to the right. What happened to the amount of Fe? Well, if we added Fe, the reaction is going to try to get rid of it, but it can't get rid of all of it. So if you add Fe amounts increase in the end. What happened to the amount of SCN? Well, it was used up to combine with the Fe. So that thiocyanate decreases. What happened to the amount of iron thiocyanate? Well, we added iron, it reacted with the thiocyanate ion, and it made more of this compound. So that would go up as well. So think about that, or go back and watch that part over again. It's kind of a key part to knowing how to do this worksheet. So in number 9 here, we have this chemical reaction, and energy is found on the left-hand side. When energy is found on the left-hand side, it acts like a reactant, and energy has to be put into the reaction, and we call that an endothermic reaction, because energy is being consumed or used to make this reaction occur. In number 10, the energy is over on this side, and we call that an exothermic reaction. The energy is exiting the reaction, and this is because energy is released or given off. In number 11, if you add energy or raise the temperature, the reaction will shift to do what with the energy? So in number 11, energy is going up. So according to Le Chatelier's principle, the reaction should shift to try to use up the energy. To do that, it would have to shift this direction and make more of C and more of D, and energy would be consumed in that reaction. So it would shift to use up that energy. If you remove energy from this particular chemical reaction, so energy levels go down, the reaction is going to try to replace that energy that is being removed. So it would shift this direction to try to replace that energy. So it would shift to the right to produce energy. Number 12, hydrogen and nitrogen react to form ammonia. Which way will the reaction have to shift if there is an increase in pressure? Take a minute and really think about this problem before you just watch what's going on. Well, when we deal with pressures, we're only dealing with gas molecules. The rest of the items, whether it be solid, liquid, or aqueous, are not going to be involved with pressures. So when it deals with pressures, we count up how many gas molecules or atoms we have on each side. So here we have 3, here we have 1, and here we have 2. So if this was in a container, if everything was ammonia, we would have less pressure in the container than if we had hydrogen and nitrogen in the container. So in other words, there is a higher pressure if we had just these guys, and it's a lower pressure if we have just this. So let's go back to the problem. Which way will the reaction shift if there is an increase in pressure? Well, if we increase the pressure, the reaction is going to shift to try to decrease the pressure. So if pressure goes up, the reaction should shift to go to the side that would produce less pressure overall. And it would shift to the right, or we can put an arrow. Pressure stress does not affect solids, liquids, or aqueous solutions. If they're the same number of moles of gas on each side of the reaction, also there will not be a shift. So gases are the only thing that are affected by pressure changes and volume changes. The only stress that will change K is a change in energy. That's going to be very important for doing question 15. Need to realize that, need to write that down, maybe put that on the cover of your unit pack. Changes in pressure occur due to changes in volume, which will change the molarity of a gas. Pressure or volume changes only affect gases. All right, so here we go. This is the main work. What we have here in our data table is going to be a shift, so we're going to put arrows right here in this spot. This is the molarity of the hydrochloric acid, molarity of the oxygen, molarity of the chlorine gas, molarity of the water. We're going to say how energy is affected and our K value overall. So we're going to fill in all this information. This will be a good chunk of your test. So in this problem, our stress is adding chlorine gas. So if we add chlorine gas, it has to increase. There's just no way about it. Whatever you add is going to increase. So if we add chlorine gas, the reaction should shift to try to use up chlorine gas, which means it's going to shift that direction. That's going to make our amount of hydrochloric acid go up. It's going to make our amount of oxygen go up. So oxygen goes up and HCl goes up. Has to. This chlorine gas, we can only get rid of it if we combine it with this water and with this energy. So the amount of water would go down, the amount of energy would go down, and our K value, like we said before, the only thing that will affect our K value is going to be a temperature change, and that's not going to occur here. And so our K value stays the same. Or we could write no change in that box. Again, right here, the only stress that changes equilibrium constant is a change in energy. And we are not doing a change in energy to the problem. The change in energy occurs because of the stress that we placed on it. All right, we're going to step down one. At some point in time, you should be trying to do these on your own before you see the answers. So in this problem, we are removing oxygen. Oxygen is being removed. So this amount of oxygen is going to go down. Whatever you remove, you can't replace 100%. If that oxygen is going to go down, the reaction is going to shift to try to make more oxygen. So it's going to shift this direction. If it shifts to the left, hydrochloric acid amounts will go up. It's these things that have to come together to make more of that oxygen. So our chlorine should go down, our water should go down, our energy should go down, and our K value would have a no change associated with it. Take a good look at that. Try the next problem before you see me do it. Pressure is increasing in this problem. That is our stress. Pressure only affects gases. Here we have 4. Here we have 1. Here we have 2. Here we have 2. So we have 5 gases on that side, and we have 4 moles or molecules of gas on that side. So if we increase the pressure, it's going to shift to the side that's got less pressure associated with it. So let me erase this right here. Again, we're increasing the pressure, so it should shift to the side with less pressure. Less pressure, there will be less pressure with 4 moles of gas. So it's going to shift that way. So I put an arrow there. Our hydrochloric acid would go down, our oxygen would go down, our chlorine would go up, our H2O would go up, our energy would go up, and our K value would be a no change. So NC, no change. Again, try the next problem before you move on. All right, now we have a temperature increase. So temperature is a measure of energy. So we are going to make the energy go up. So the reaction should shift to try to get rid of the energy. So the reaction is going to shift that direction. I apologize for not putting in arrows in the last one for the shifts, but just look up here and it'll tell you which way they're shifting. So if we are shifting to the left, HCl should go up, H2O should go up, Cl2, H2O, and the energy have to come together to make the stuff on the left-hand side. So Cl2 is going to go down, H2O is going to go down. Energy, we're adding energy. You can't get rid of everything that you add. And our K value will, in fact, change in this instance. So we have less products, less of the stuff that's on top. Remember, this is what the K value is. So we're going to have less of the stuff on top and more of the stuff on the bottom. So K value will, in fact, get smaller. Hopefully you go through and try these problems on your own rather than just copying down my answers. See you in class. Come in for help if you need it.